Hello, and welcome to our session, The New Frontiers of Manufacturing, Additive Manufacturing in Aerospace. This session will highlight additive manufacturing's uses within aerospace, where our panelists will talk about applications, current trends, and how additive manufacturing is affecting production and innovation. Our panelists are Alyssa Ruiz, a research engineer at Lockheed Martin Space at their Advanced Technology Center, or ATC, in Palo Alto, California, where she's been working for the past 5 years with a project in analytical focus and thermal engineering. Lisa has worked on projects from electronic components to satellite system level. She has been the 3D printing liaison for her site for the past 3 years, enabling engineers to get prototypes of their designs manufactured quickly. Lisa is an alumni of San Jose State University with a BS degree in mechanical engineering. We also have Luke Colby, President and CEO, Triton Space Technologies. Luke holds a BS and MS in aerospace engineering, and prior to founding Triton Space Technologies in 2014, worked for 10 years as lead propulsion engineer for the rocket motor developed for Virgin Galactic's Spaceship Two vehicle. During that program, he was involved with all aspects of the propulsion design, as well as ground and flight test operations for the complete rocket motor system. Triton Space Technologies is based in Woburn, Massachusetts, north of Boston. I'm the session's moderator, Eric Brothers, senior editor of Aerospace Manufacturing and Design, the only North American magazine exclusively dedicated to the design, manufacturing, and maintenance, repair, and operations of aircraft and aerospace components. Since we're based near Cleveland, Ohio, our session group geographically represents the US West Coast, East Coast, and North Coast. A few notes before we get started. You will have an opportunity to ask our experts questions at any time during the presentation. However, we will wait until the end of the presentation to answer your questions. You may ask your questions by typing them into the Q&A question box visible by rolling your mouse over the bottom of your Zoom screen, and we'll do our best to get through as many questions as possible. Lisa, Luke, let's get started with 3D printing additive manufacturing's applications and the way technology has helped you. Lisa, how do you use additive manufacturing for prototyping?
For me, a lot of what we'll do is pretty much get the design, get the CAD model from engineers, and then be able to prototype and iterate pretty quickly on different little features or different parts of a design to be able to get this out from our engineers to the test bed and have that done pretty quickly with a pretty quick turnaround.
I'll flip it over to you, Luke. How do you use additive manufacturing for reducing cycle time in development, and how much time do you save?
Sure. So we primarily, to this point, have used additive manufacturing for doing functional mock-ups and prototypes of components we'll design and then manufacture. So, for example, if we're building a high-pressure pre-valve for a rocket engine assembly or something like that, I actually have so here's sort of an example of a prototype that we made where we'll do a functional mock-up printed in plastic, and the tolerances of the MakerBot printer we're using are good enough to be able to put it together in a functional test article and just make sure everything fits together. You can get the wrenches where they need to go to do assembly, make sure the parts sort of slide and fit as expected. And that gives us confidence to then go and produce an actual prototype part in metal. And primarily for our business, we still do most of the stuff subtractively. So we'll use the 3D printer to sort of like front end load the design cycle and make sure that we check the fit and function and make sure that we haven't forgotten anything by actually having the design in hand. And then once we've sort of checked that box, then we'll go ahead and actually manufacture a real part. And so we do all our machining in-house, so our turnaround times are already quite fast because we keep control of that directly and we don't outsource to outside machine shops. But by having the 3D printing concept phase to begin with, we save ourselves a couple of weeks probably of machining a component only to realize there's something wrong and then have to make a new one. So it's been very helpful for us in that regard.
Thank you. Lisa, do you use additive manufacturing for fit checking as well?
Yes, yeah, I definitely do. I think a good example of one of the ways that we've used it is once you've pretty much built up an assembly entirely, you'll need to do cable routing, and cable routing is a huge part of, once you have the actual mechanical design and everything assembled, you need to route all of your cables for your electronics and sensors and different things. So being able to have either an assembly small enough or a printer large enough to be able to print your entire design out, print out a mock-up, and be able to physically route the cables that you're actually making is definitely something that we've been able to utilize it for. So a lot of fit checking for creating cable routing, as well as fit checking just for general parts and other projects that we do. There's also some things that we'll do with some sensor mounting for different test beds, as well as I think one thing that we've made a lot is interface plates. If you have some parts that maybe don't exactly go together in your assembly, or there's something that's slightly off, being able to quickly turn around an interface plate that otherwise would have taken a really long time to design and procure really makes it easier when things aren't either fitting correctly, or to be able to make the fit check kind of work.
Okay. Do you also use it for tooling?
Yes, yeah. So a good example of tooling that I can kind of give is, we had one project where we needed to make a spring out of a metal tube. So it had to be wrapped in a pretty precise diameter and had to be coiled in a pretty precise height to be able to fit in our assembly. And coming off of that coil, there were some pretty difficult bends where the rest of the spring interfaced with another part as well. So myself, and that was a project that I personally worked on. So being able to actually design up and print that tooling that enabled us to make those difficult bends, as well as the coil without kinking the tube, which was kind of the most difficult part. It had a really thin wall. But being able to really just kind of create something out of thin air and have your design, test it out, iterate it, and have essentially another tool just printed and ready the next day to try, was actually pretty fun for that project. So that, at least for tooling, that was a pretty big one for us.
Okay. Luke, do you also use additive manufacturing for tooling or jigs and fixtures?
Yeah, we do. So we use we'll use plastic jigs and fixtures that we 3D print for assembly processes. So let's say we've got a high pressure valve or a rocket engine assembly, and we're stacking up a bunch of components and having to assemble them and make sure everything stays aligned and that the seals are in the right location, all that kind of stuff. So we'll print out plastic sort of fixtures that will help us just sort of place everything where it needs to be, and hold it in place to do an operation. And normally, we probably wouldn't go to the trouble to machine an aluminum or steel fixture just to do partway through an assembly process. But because it's so easy to 3D print stuff, we'll print several fixtures for one assembly operation that in the past you might have only made one or two fixtures, and so we find that the plastic ones are so easy to make. We'll make them and then we'll adjust them if they don't quite work. We change the model a little bit, and so it's that's actually where we find the sort of the most value at the moment, is that it helps us with our production and assembly process of just putting together finished metal parts, and allowing the technicians to assemble stuff smoothly, and having sort of staging along the way is how it's helped us out. I think so. Like this is just sort of an example, sort of foundational base for an assembly where other components will sit on top of this, and then we'll do some other stuff. And there's probably 4 or 5 fixtures that are kind of like this for a total assembly process. But by having something like that, this would have taken a while to machine. And we probably wouldn't have bothered, but because it's just 3D printed, we're able to do multiples of something like this for each stage along the process.
So how much time can you save, Luke, in develop using 3D printing?
It's hard to say. I think we basically find that we have less errors in processes because of the 3D printing that we're using. So it's a little hard to say because things just go right. So, but basically, I think you could probably say we're saving 15–20% of time because there are not as many issues or problems through the whole process, and so we find that that's valuable to us.
Okay, Lisa, do you have similar time savings to report?
Yes, yeah, I think I could probably say for some of our more complicated pieces of tooling that we would have had to send out for, we could probably, I mean, we probably do save somewhere on the order of from weeks to days and sometimes even hours if the print is short enough. It's definitely really, really helpful, at least for us being a government contractor for Lockheed. Our procurement process is pretty bureaucratic and it makes it pretty difficult to kind of have that quick turnaround of parts. So I would definitely say that it can turn weeks into days and it really helps our engineers out a lot. That's
good to know. Does the process matter, whether it's material fed or material bed? Or is it the properties of the part, the additive part that you're seeking? So I think for us, it's really the properties of the part that we really need. So a lot of it is just dimensional, at least for what we're doing with prototyping and fit checking. So really just the end result, the resolution is what we're looking for. I mainly deal with PLA and plastics. I don't have, I can't really speak to metal printing, which is also really cool. But at least for us, it's a lot for the fit checking and we need the resolution for the part. So it's a lot more the end result. Okay, I'll throw the same question at you, Luke.
Sure.
Does the process matter as much as the properties you're seeking, or does one influence the other?
Yeah, so again, similarly for us, the value that we have with 3D printing for the most part is the quick turnaround and the dimensional accuracy. So we'll print prototypes and jigs and fixtures out of plastic on our printer in-house and do that over the course of, we'll set up a model the night before, hit run, come back in the next morning, and the part's done and we're ready to use it for whatever we're doing. So for most of what we're doing, that's kind of where it's useful for us. On the other hand, we have had a few projects where we have actually used metal 3D printing. In that instance, you're less concerned about the process and the time than you are about the end result where, for example, we printed a liquid rocket engine combustion chamber where it has the cooling channels integrally printed into the construction. And so that's something that we couldn't have machined subtractively. So fundamentally, the metal 3D printing was worth the extra time and money and effort to print it in metal so that we could get features that we couldn't have made subtractively. And so we do a little bit of that, but we primarily right now are still doing the 3D printing that we do is in-house stuff where the dimensional accuracy and the turnaround time is what's useful.
So you're set up for subtractive manufacturing. Do you post-process or machine the additive parts you make?
So for the plastic ones, we've found we don't really have to, but for the metal ones, absolutely. Yeah. So for example, like I said, we've printed combustion chambers before. And so even with the best metal 3D printers, they're still going to come back to you with sort of I guess I would say it's somewhere between an investment cast and a sand cast surface roughness. So those surfaces are definitely not smooth enough to have mated flanged interfaces or O-ring seals or any of the kind of things that you need in mechanical assemblies. And so we'll get a metal 3D printed part made, and then we'll bring it back and we'll kiss the surfaces that are important to us for sealing surfaces or mating surfaces. And then typically, and I know some people have been able to 3D print threads in metal parts and just use them, but for what we've done so far, we'll generally print the location of where the hole is going to be solid, and then go back and subtractively drill a hole and then thread mill it, so that we can hit the tolerances on our thread classes just right, because the metal 3D printing still isn't really there for that kind of stuff. So very much when it comes to metal 3D printed parts, it's a hybrid approach where you build up the stuff with metal and then subtract it away again with machines. So,
all right, thank you, very informative. Lisa, I want to go back to you. You mentioned PLA among your the materials. What are your go-tos, or what are likely to? Do you use any carbon fiber embedded resins in your work, or foresee that happening soon?
Definitely, yeah. So I mainly print in plastics. We do have an SLA resin printer that we've been utilizing just a little bit, but yeah, for the most part, I do just use PLA. We just got a new printer that's that has all of the parameters set and works pretty well with the heated chamber for ABS. So that's something that we're starting to print a little bit more. As we know, it's kind of difficult to print with ABS, but that's enabling us a little bit more. But as far as the carbon fiber infused plastics, I think it's really interesting. With our new printer, we actually have the capability of printing with that. We haven't had any projects as of yet that sort of need that. It is a lot more of an end of use product. You can actually put it to the test, and it has the mechanical properties that you might need for an end of use product. So we're still looking for some projects to be able to utilize that with, but as of now, I'm pretty excited about having that capability at all. So
okay, so just as a follow-up, what materials or capabilities, such as physical attributes or temperature ranges, would you like to see if you had a wish list?
Yeah, I think for us, there was an interesting article that came out. I don't exactly remember when, but being able to utilize 3D printing and plastics for cryogenic applications. I don't exactly know where that is right now. I can't speak so much to it. But being able to go really cold, I think, would enable us a lot. Being able to 3D print and qualify certain parts for flying things on cryocoolers, or really using 3D printed parts for cryogenic optical systems would definitely be, I think, the kind of next step for temperature ranges that we'd want to look at.
Okay. Luke, do you have a wish list for materials, and what ones do you consider your go-tos?
Yeah, so I mean, for the stuff that we print in-house, we primarily use ABS and the support material, dissolvable support material. But we have also printed some parts in carbon fiber nylon, and so just sort of as a experiment to see how good the material would be for so in subtractive manufacturing and machining and milling, you'll oftentimes hold a part on the second operation in soft jaws, and those soft jaws are machined to sort of the shape from the first operation, and you'll hold the part usually in aluminum, or if it's a production part or a higher strength part, it'll be in steel soft jaws. And we still primarily do that, but just to sort of try the process out, we have tried printing carbon fiber nylon soft jaws and using them to hold aluminum parts for a second operation. So it was sort of a surprise to us that the carbon fiber nylon material is stiff enough and rigid enough that it actually worked as a soft jaw material. Now, the for this particular application, the print time didn't really justify it because you're still building the thing up solid and in solid layers. A regular soft jaw is 4 or 5 inches thick, so the total print time for that part wasn't something that would make us turn around and go out and do that on a daily basis. But it was interesting that these newer materials have greater stiffness and can actually be used for an application that typically you wouldn't use a plastic for. But in terms of sort of wish list materials, I think for us, the stuff that's more interesting and compelling long-term is on the metal printing side of stuff. And so we're more interested in sort of the different class of metal 3D printers that are becoming available. And I know that this is a MakerBot session, so I don't want to go too far off course, but there are some other companies, one just down the street from us, Desktop Metal, that has some interesting powder-based technologies that we're very interested in. I believe MakerBot is also working on an FDM version of metal material. So we need to look into that, but at this point haven't used it yet.
Okay, I'd like to turn the conversation now to some of the current trends in additive manufacturing. And certainly one of the current trends is working remotely. So has the pandemic, COVID-19, changed how you use additive manufacturing in any way, or made it more desirable to use that? And I'll let Lisa answer that one first.
Yes, so I think at least for the pandemic, how we do print is on our own network. So we don't use any sort of like cloud-based sort of software. So you kind of have to be on the network to be able to print anything in-house. So at least from our standpoint, if you are modeling or designing something at home, you would either maybe send it to a coworker that was on site or have to come on site yourself to be able to actually print it. But I can see at least the trend for remote work and collaboration with additive manufacturing kind of growing. If you even kind of open up the scope a little bit from other companies to other countries, even saying your team member maybe in another city, another state or country has a part STL file model that they want to be able to share with you. And you have a printer, you can actually just get that file printed out and be able to have something that you can handle. And I feel like that can really, or that does really just empower innovation and empower collaboration to be able to communicate well and have something in hand across teams and across different lines.
Okay, very good answer. While I have you, what other trends are you seeing? You obviously use the additive for prototyping and fixturing and tooling. What's probably the next thing down the road that additive will be used for, do you think?
I think at least the trend of how it's going now is moving past prototyping into end of use products. Definitely additive manufacturing as a whole outside of plastic printing, as Luke was mentioning, for metal printing, I think is definitely the next trend and kind of the next level and step up to be able to have these end of use products, to be able to make structural features that are not traditionally machinable and be able to have those just inherently embedded and apart from the get-go, I think is really interesting and definitely where it's headed. At least for us, I can give a little bit of a plug to our Sunnyvale facility at Lockheed. There is an additive manufacturing center where they do a lot of metal printing. I'm not really a part of that, but it's definitely at the forefront of our minds to be able to have those end of use parts created with additive manufacturing.
All right, thanks. Luke, I see you nodding
Yeah.
in approval. What do you see as the coming trends?
Yeah, so I think I agree that the metal area in 3D printing is definitely the most interesting and compelling. The plastic stuff has been fantastic for all the things that we've talked about previously, but I think long term for getting 3D printing into the sort of end use production parts, really the metal parts I think are going to be where it's most compelling. The biggest thing we've found so far is that unless the part has a specific requirement where it really can only be made with 3D printing, for example, a combustion chamber, our customers have been reluctant to say, you know, hey, can you take something that you currently make subtractively and make it additively, because there's still a sort of hesitation with you know, how do we qualify the material properties? How do we know if there are inclusions, things like that? And so that's an area that I think is going to need more focus. But I think as time progresses, we will see more and more metal 3D printed parts just accepted from the get-go as, oh yeah, that's a perfectly acceptable thing to do. And I think we're just kind of on the cusp of that right now, where it's more focused on, well, we'll accept it because there's no other way to make the part. So, so we'll figure out a way to make sure that we're happy with it, as opposed to just everything we make is made that way. And I think in the future, it will be lean more in the direction of, you know, everything's metal 3D printed, at least metal parts, obviously.
Right. Well, obviously, plastic has advantages for lighter weight, you know,
Yes.
for than metal in a similar item. Did the pandemic affect the way you used additive manufacturing, Luke?
Not especially. We, like I said, we will print. We already use the process where we'll print remotely from home and, you know, send it to our computers here on our local network, and then they'll print overnight while people are at home, and then come back in the next day, and the part's done. So we're kind of already doing that. So it hasn't really changed the way that we use it, but it is an enormously powerful thing, because there have been multiple times when you know, I'll leave for the evening and the part won't quite be ready, and then 6, 7, 8 o'clock at night, it'll be like, okay, now it's ready to print. Just send it off, and you still get that print cycle in without having to wait to the next day to show up, hook up to the printer, and print it while you're physically in place. So yeah, I think the remote connectivity of these devices is great, and I think it's only going to increase in usefulness over time.
Okay, Lisa, we talked a little bit about using additive manufacturing for production parts, and you know, that's obviously coming along. I wanted to know if you think in additive, that is, do you design parts for additive from the start, or do you adapt existing designs? And are you sort of in between on that process? And do you have any examples that you could share?
Yeah, so I think for us, at least, most of the parts that we do design, we don't design for additive, and we usually will have to adapt them. There's many different things that will say, oh, maybe we'll want to 3D print this, but it just kind of won't exactly work out. So I think it's something that we do need to adapt a lot of existing designs if we do want to 3D print it, fit check it. But in terms of fixturing and tooling, I think we will think in additive manufacturing minds. For my example with the sort of tooling that we used for the spring coil, that definitely had its sole purpose was to be 3D printed. So we definitely kind of went through that thought process in designing. So it does depend on what you're trying to do and what you're trying to make. But I think I would say for the most part, we don't think in additive manufacturing minds. We're kind of trained traditionally. So, but I can see that changing, especially with the next generation and those in school now. So.
Okay, Luke, I'll throw that same question to you. You had mentioned at one point that you do a lot of valves, and that's sort of a traditional shape and design. Yeah. Is it possible to kind of think additively on on how you might take some weight out of a typical valve?
Yeah, so we do think about those things, and I think that's the direction we would like to take things in the future. Like I said, if we can get our customers buy-in to where they will accept designs that are 100% 3D printed, I think that is a direction we want to head in. And there's no question that it does require sort of a rethinking of how you will do a design. Right now, most of our designs are from the outset are based subtractively, and our product line is still subtractively manufactured for the most part. Like I said, there are a few sort of boutique items that we have done additively, but we're definitely not yet at the phase where our designs are from the start are geared towards additive, and that's primarily, I think, at this point, less because we don't think that way and more because we know that it's not what our customers are looking for just yet. And so I think there's still a little bit of growth there that needs to happen, but there's no question that there is a different process that you take when you think in terms of making something from the scratch for 3D printing versus you design something that you expect to be subtractively manufactured. So yeah, I don't, maybe that's not a great answer, but yes, we still are primarily subtractive, but we're hoping to lean more in the direction of additive.
All right. Well, some have said that there's a dichotomy that, it's either subtractive or additive, but others are saying, well, it's just another tool in the toolbox. Some things you might want to use additive for, or that's the only option you have. Lisa, is that something that you've thought of, that at some point, you're just going to look at a problem and say, yeah, is this additive or subtractive the best way to go, rather than I've already got a part and I just kind of need to make it out of something that'll happen much faster and at less cost, which is good too, but.
Yeah, definitely. I think at some point, yeah, we can train our thinking to sort of have that branching design type or style that might be more applicable to what we're doing. So I think, yes, eventually being able to say, oh, I should make this additively, and make that decision kind of at the forefront of the design would be pretty interesting. And I think it could go that way.
All right, well, I have you, Lisa. Where do you see additive manufacturing empowering innovation? You've kind of hinted at that already and given us a few examples. Where do you see the future of additive manufacturing in aerospace?
I think it would be pretty cool, at least in aerospace, to have additive manufacturing kind of in conjunction with like artificial intelligence and designing. So I did see a talk, I think it was even a couple years ago now, just about a optimization software for design, that essentially you take your model, your initially designed model, plop it into some optimization software, and it essentially will take any structural like features or additional things that you might need for the function of your design that might not be able to be traditionally manufactured, and actually have those features placed into your design to be able to have it be more functional, but be designed for additive manufacturing. So I think certain things like that, at least for innovation, is pretty interesting and might be where we're headed towards for the future. Just, I mean, as we continue to try and optimize things as best as we can.
All right, Luke, I'll give that same question to you. Where do you see additive manufacturing headed in the aerospace realm?
Yeah, I think I would agree with the previous sentiment, because I think that so probably maybe not in the next 5 years, but in the next 15, 20 years, there will be more and more stuff going on in space And I think there will be a strong driving function to build things that are optimized to meet a certain design criteria or objective functions, and then use the minimum amount of material, be as light as possible, will not be constrained by it needs to work in the atmosphere. All of these things that I think we will see increasingly structures and objects that are designed and built in space to only work in space will not look like things we're used to seeing. And I do agree that that's where additive will be able to help a lot, is to take that sort of fusion between an iterative design, generative design process and additive manufacturing to make components that are wholly unique and optimized for the spaceflight environment. And I think, to me, that's the stuff that's kind of exciting and interesting, is that these, we sort of, sci-fi sort of shows us, the spaceships of the future are kind of boxy and like basically built the way, cars and planes are built. But I think the reality is they may actually not look like that at all. They may be much more swoopy and organic, because they will be made through optimization of objective functions that are searching for, where do I need to put the stress through this part so that it can take the loads when this vehicle is under acceleration and things like that. And so that may result in things looking very different from what we are used to seeing things look like. And so I think that's pretty exciting and will be fun to watch over the next 15, 20 years, I would say.
Yeah, thanks, Luke. That's very compelling. These very bionic shapes where they're very stretched out. I can picture a spaceship perhaps looking like that. So we have a little time left. I'd like to go to some of our viewer questions, and you can jump right in. Both of you, what sort of software do you use to design?
I'll take that one. For us, at least at Lockheed, we primarily use Creo. I think a lot of the software maybe coming out of universities will be SolidWorks, but I think it's also moving towards Creo as well. But at least for us, it's the majority Creo.
Okay. Luke?
Yeah, we use SolidWorks. We have customers who use both SolidWorks, Creo, and CATIA. We actually, so a lot of our subtractive manufacturing, CNC machining, we program using an Autodesk product, HSM Works. And so we sort of have this fusion between competing companies working on the same machine but it, we're the products that we're using are what we need to do the things that we're doing. And so and I think that probably when we started the company, we chose SolidWorks just because of the industry adoption of it. So that was probably a driving factor, although I think the other alternative tools that are out there are growing in popularity.
Okay. I have a question here that was from Jude. I have a question here from Gary. It says, I teach STEAM, that's science, tech, engineering, art, and math, to 1st to 8th grade. Currently, I teach basics, what engineering is, the different branches of engineering, the engineering design process, for which 3D printing is awesome, he adds. What should I add to that? What should I be teaching at the elementary education level to prepare my kids for jobs like yours? Lisa, I'll let you answer that first.
All right. So I think that's great. I love STEAM. I also love the concept of getting technology and engineering in conjunction with art. And I think additive manufacturing and the capabilities of 3D printing and design really encapsulates STEAM. My first introduction to 3D printing was in high school. So I think having that introduced much earlier on will definitely enable and empower young minds to think differently. So I think including the design process in a simple way, and I've seen it kind of used as an analogy with even writing, to where you have your initial draft essay and then you kind of revise it and go through these different processes, and kind of just having that analogy to kids, I think kind of helps bring an art mind and a technical mind kind of together, and really enables that sort of STEAM thinking. So I think, yeah, analogies to technology in other ways that kids might be able to understand would be something to rope in there.
Okay, Luke, do you want to weigh in on that topic?
Yeah, so I think that yeah, it's sort of a fascinating thing, because I think that one of the things that our schools currently do not do well enough is to teach kids at an early enough age what engineering is, what the science and engineering fields are, and just how fun and rewarding this stuff can be to work on. And so getting kids excited about the process of thinking about how you would design something and then actually manufacture it as early as possible. And 3D printing helps with that, because obviously heavy industrial manufacturing processes can't really be brought into the classroom. So the 3D printing sort of revolution, I think, has helped a lot with getting kids able to understand that, hey, I can think about something and then I can actually turn it into a real thing, and it can actually do a function, which I think is not well enough emphasized in our education, where kids are not really aware, even all the way up to the high school level, what engineering is. And they've kind of heard about mathematics and physics and stuff, but they don't really understand the difference. And there's an old Apollo era engineer that I worked with years ago, and he had a great saying that I enjoy. He said, you know, when people, so I happen to be a quote unquote rocket scientist. I do work on rocket engines and stuff like that. But he said, you know, never when people call you a rocket scientist, you're really a rocket engineer. And the reason for that is that scientists merely study things that are, engineers build things that could only be dreamed of. And I think that's I like that as a sentiment. And I don't mean to take anything away from scientists, but I think as a sentiment, it really gets at the heart of what engineering is about, is that we take something that we imagine that's an idea in our mind, and we turn it into a physical reality. And that's kind of a unique field of human endeavor. And it does very much combine sort of the imagination of art with the mathematics and physics of science, and merge them together into a field where you're able to make things that are not only functional but beautiful, and function and provide a positive impact on society. So I think that's definitely something that kids should be made more aware of early on in their education.
And if I may add, I've seen excellent examples where high school kids who seem to love the technology have been used to help train or teach the techniques to elementary school students. So I mean, it's sort of a big brother or big sister mentor, but it works, and it's probably accessible to a lot of elementary school teachers. So
yeah.
Well, I see we're just about out of time here. I'd like to thank our speakers, Alyssa and Luke, for sharing your experiences with additive manufacturing and your very important insights on additive manufacturing. And I'd like to thank our session attendees for their questions as well, and for their attention. Again, thank you all for your participation. And hopefully we got through enough of your questions. And thank you again.